regression. Plane of regression, how it will be the exist. The plane of regression, how it will be the exist. That is the overall idea we can get by the x1, how it will be the depends on the other two variables. Here, I'm taking the x1 is a dependent variable. What I selected here, you can see x1 is on x2 and x3. And here x1 equal to a plus b x2 plus b1 to x3 and b13 to x3. So here x2 and x3 is clearly on the x1. So here independent variables x2 and x3, so that it is a regression coefficients are x1 on x2 and as well as x1 on x3. These two we can be check and we can say that. So that is clearly we called as a regression of x1 and x2. X1 and x2, x1 on x2 and x1 on x3. This is the overall idea on the regression coefficients. Now coming to the regression coefficients and the regression equation or plane of the regression. Plane of regression representation is clearly here. The 5.2.1. This is a plane of regression, what I selected. No, it means that this is only the. This is a 5.2.1. This is a plane of regression. Plane of regression. Now, plane of regression, it is a what is saying that is a Yule's notation. Yule's notation is a 5.2.3 is called as a, this is a Yule's notation. This is called as a residual of error in the estimation. What I selected, that is called as a Yule's notation. In that coefficients are B123 and B132 are partial regression coefficients of order. So it is a secondary subscriptions if we take that is involved in the only one involvement. So it is a different kind of the observations on x1 on x2 and x1 on x3. Such a way we want to be rectify that it is a corresponding errors. That is a notations here we can see here is the residual or the errors in the estimations. That is clearly x1 to 3 equal to x1 minus e1 to 3 and x1 minus b1 to 3 and x2 minus b13 to x3. So this is called as a Yule's notations we call. In that notations, what he will tell that means it is a secondary subscriptions or primary subscriptions. These are the two subscriptions. It means that it's an independent variable. It is a subscriptions only. Second subscription here x2 and x3 are the two variables. Clearly subscriptions on the x1 only because of independent variable. Order of the regression coefficients depends on the number of secondary subscriptions. It is a regression coefficient depends on the number of the secondary subscription. That is called as the order of the regression coefficients. Clearly depends on the number of the secondary subscriptions. So here B123 and B13 are the partial regression coefficients of order 1 because they involve there is a one subscription to the secondary. It means that it is a x1 on x2 and x1 on x3. That is overall to second point of the Yule's notation. Next, third point comes to the order which is the second subscriptions are mentioned is the not important. As not important means it is a coefficients are the not important. No, it is coefficients are the important, but it is a thing is it is a total overall. It is a both on that it is a dependent variables are dependent. And x1, x2 coefficient and x3 coefficient on that it is x1 is dependent. So it is a individually we cannot be think over that. That is information about it is order in which the secondary subscriptions are mentioned is not important. However, the order of the primary subscriptions is mentioned. Primary subscriptions means it is x1 on x2 coefficient. It is clearly observation is required. And x1 on x3 coefficient is observation is required. That is comes to the here primary subscriptions on the so that x b12 and b21 of our dependent variables on independent variables. This is the overall idea about the Yule's notation. Next, equations of the plane. Equations of the planes. I will write on the board equations on the plane. How we will be resolve this issue. That is comes to the it is a notations. It is a notation solving of that we can go for the coefficients solving. With that we can say that it is a how the solutions we can be getting. Then we can go for the problems. I am sharing board. Now, here we can see that is a general example. I will tell that it is a instead of B123 and B213, instead of that, I am taking the ABCs are the constants. That is the BCs are the coefficients of X2 and X3. Like that, I will take it here equation. So the plane equation, regression plane equation, y equal to A plus B X1 plus here B X2. Here, how many variables are involving? X2, Y, X1, Y, X1, X2. These are three variables. If this equation, instead of that, we can take like this also. X1 equal to A plus BX2 plus CX3. Otherwise, X also we can take. It is a no issue. It is a variables or we can take that is a whichever we can take, that is only the conservable. Now, here, simply here, error part I want to remove. Sir, what is the meaning of this one? It is clearly diagrammatically, if we write, this is a scattered points. Etc. I explained that. Same thing. These are the scattered points. In that scattered points, I am joining this line. I want to pull on the line. Equation means it is a plane equation. This is a plane equations means these are points at different areas. This is x-axis and y-axis. I'm taking this is a x-axis and y-axis. It is a plane. Each point is coordinates, that is x comma y. If I take that is another variable also said, then one is depends on the other two also. So it is a z-axis plane as it comes to the here. Now it is a, if I take into the variables are x1 and x2, two variables on that, it is a single variable, how it will be depend. I want to take that is a two ortho, I want to pull on this. All points on, I want to pull on that. It means that here clearly pulling is goes to the here, from to here to on that line, here to on that line, and here to on that line. The distance is clearly, we say that this is the point. This is point A comma B comma C. It means that it is a x-axis distance is a. X-axis distance is clearly A. Yeah, this is a A. This distance means it is a clearly, it is a so far from the origin to A distance we have. This distance I want to pull on that line. This equation line equal to y equal to A plus bx1 plus cx2. A plus bx1 plus x2. So here similarly, the distance of this point is a B point. Means it is a distance. This is the axis distance. This point I want to pull on that. Where is that? This point also, and it is the B point. B point also y directions distance. It is a pulling on that, and z axis also it is having some distance. I want to pull on that. This is called as a plane observations. Plane observations. Plane observations here, 2-dimensional observation, 3-dimensional observation, 4-dimensional observation. One scatter points, that all the scatter points, all I want to bring onto the straight line. There we get that is a residual errors. That residual errors we want to be minimized. So here variables are involved. There it is clearly here y equal to A plus bx1 plus bx2. That is I'm taking that is the equations. Oh, sorry, cx2. Now what I'm going to here, I'm taking that is an error E1 equal to what is that y1 minus. Here we will change the variable names. Okay, and instead of that I will write that is a directly I. So here yi original value minus A plus bxi plus cxi whole square. So what happens is this is a x1 and this is a x2. These points we are making the errors, residual errors. Here E1 square. This is a first part, ith term error. Now sum of all the terms if I take, that is called as a summation. This total summation is outside of this is error. Summation of the error. Here ni equal to 1 to infinite. How many points you will take? That is number of points. finite points. Here I equal to 1 to 10. All errors and deviations I am taking here, that is called as a residual error. That residual errors is I am denoting capital E equal to summation yi minus a plus bxi plus cxi whole square whole power 2. Now here, that is I want to make it the derivative dou E by dou A equal to 0, dou E by dou B equal to 0, and dou E by dou C equal to 0. Then the residual errors I will make into the zeros. Residual errors I will make into the zeros. So it is a residual error or make it the zeros means all the points are logged on that state line only. Login on the state line only. So state line is constructed. That is an equation is called as a regression equation. That regression equation point of view, I am going to construct the normal equations. Normal equations. So here normal equations are first normal equations means it is a dou E by dou A equal to 0. So here, what are the variables? We have two variables. So originally here we have a y equal to a plus bx1 plus cx2. No, if I take that, it is clearly a summation of y equal to na plus b into summation x1 plus c into summation x2. This is called as a normal first normal equation by using this dou E by dou A equal to 0. That is comes to the here. So coming to the second part of the simplification, dou E by dou B equal to 0. B by B equal to 0. What happens? Y equal to here x1 term we should multiply so that it is a yx1 summation x1 I am multiplying equal to a into summation x1 plus b into summation x1 into x1 sorry here first part a into summation x1. Yes, correct. Plus b into x1 into x1 square summation x1 square plus c into x1 I am multiplying x1 into x2. This is comes to the second normal equation. Now we go for it is a third normal equation we can get by using dou E by dou C equal to 0. Dou E by dou C equal to 0. What happens? Summation y into x2 if I multiply a into summation x2 plus b into summation x1 x2 plus c into summation x2 square. So this is called as a third normal equation. So from the normal equations from 1, 2 and 3, three normal equations if we solve, we get that is we can get that is a b, c. That a, b, c are the coefficients of the regression equations. Now this equation if we substitute a plus b x1 plus c x2, this is called as a equation of the regression equation. B and c are regression coefficients. Regression coefficients. So here regression coefficients, if I take the b means b is a regression coefficients. It means that y on x1. And the regression equation c, if the coefficient, if I take the c, it is clearly y on x. It is clearly depends on that, so that it is clearly it is a primary subscriptions of the coefficients. That is I explained. That I explained by the Yules. Coming to the two variables at a time, it is involvement. It is somewhat it is difficulty. It is called as a secondary. Secondary is it is a total individual patients. It is difficulty. So so that we cannot assess anything else. Both it is needed. Both coefficients are needed. Then only equation is performed. That is a correct equation. So this is an analysis is clearly is called as a regression coefficients of the two variables. Regression coefficients of the two variables. So this is a oral idea how we are going to discuss that total concepts. Okay, ma. Understood, Anand? Okay. Now, I'm showing here how they derived here. Simple, what I explained similarly, they will explain here once you can see. Coefficients are the somewhat it is a different way. Rules is over. Equation of the plane of the regression. 1 second. Now, here, if I take this as an equation, my screen is visible now. My screen is visible now?
Yes, sir.
Okay, fine. Equation of the plane of the regression. It is clearly we can take that this is a regression, but two partial regression coefficients are I am taking this one and this one. Okay, these are the coefficients. Here, there I shown that is a B and C. Subtractions here we have taken that it is a no issue. Here all at a time. This is a x1 is a instead of x1 is a there I denoted y. There is a y. Y minus these two I am taking one side. It is a whole square is error I am removing. So error part if I remove and coefficients it will be multiply that dou s by dou b equal to 0 and dou s by dou c equal to 0. So I'm getting the two equations. Here what are those coefficients we are getting? The same equations I'm getting. So here this is called as a normal equations. Normal equations. From the normal equations if we solve we can get that is our required solution of the AB, BC. That BC if is substituted I can get that is a regression equation. Regression equation. Now, here variance, how do we observe? Find out. That is a second concept. Second concept. So, in that second concept, if we take that is a sigma square equal to already xi square we have. X data he has given. So, x1 data we have given. That x1 data he have given, x1 variance we can calculate sigma 1 square. That's all. Now it is the covariance of x1 and x2 if I take, that is the summation xi x2 divided by n, I will use the formula. So covariance of in between two variables I am taking. So the corresponding x1 data variance and x2 data variance, both I will calculate. Both variance with standard deviations, root of variance equal to standard deviation. So here formula is a covariance of x1 comma x2 two data's covariance. I will calculate that by using summation xi yi by capital N formula. Covariance is over divided by sigma x standard deviation. First data variance standard deviation I will calculate. Second data standard deviation I will calculate. And the total number of elements n. So it is called as a regressions coefficients I can get. So using the relationships I can get this is a relationship. So Cramer's rule if I apply here, each one of the relationship coefficients we can calculate by using this way also. Coefficients we can calculate by using this way also. So sigma 1 by sigma 3, 1 by 1 by 1 by. Here when we multiply this one, it is R1 to sigma 1 Okay. Now, here clearly we can do this is a matrix. A defined matrix means it is a coefficients of regression coefficients of equations. So we can take it is called as R1 to R13. This is a how we can be derived the above coefficients, regression coefficients, these two. Here numerator W1, this is called as a numerator part is called as a W1, W11 and the denominator part W12. Like that, I will take here W12 and by W11, W13 by W11. So here I can get that is x1 by sigma 1 W11 plus x2 by sigma 2 into W12, x3 by sigma 3 into W13 equal to 0. Properties means it is a sigma x2 into the coefficient. That is the same simplification, so we can do it. Next here, error part of the subscription of the first part also we can do. Now, exam point of view, problems he will ask like this. Sigma 1, sigma 2 and sigma 3 will give 3 standard deviation. Sigma 1, sigma 2, sigma 3, 3 variable data we have. Sigma 1, sigma 2, sigma 3, 3 variable data we have. Next, it is a R12 equal to 0.7, R13 0.6, R23 is a 0.4. Find the equation of the regression plane x1 on x2 and x3. So here, as per that, we have a formula W equal to. What is asking the question? Find the regression equations. X1 on x2 and x3 is asking. First, it is I want to find out that B1, 2 and B3, 1. So that like that the coefficients I want to identify. So if I identify the coefficients, then directly I can write that's the equation. So main target is here he has given that is a sigma 1, sigma 2, sigma 3 and R12, R13, R23 he has given. So directly we can go for that is a regression coefficients. If we identify directly equation, I can write. So now I am writing that regression coefficients. Here W equal to 1, R12, R13, R21, 1, R23, R31, R32, 1. So here coefficients of the coefficient of the elements ith row and jth column. Above matrix is we can take it here. So here formula is W12. Here B12 equal to sigma 1 W12. W12 here W matrix is W matrix is a W here coefficients matrix R12. R12 what he has given? Yes, he has given 0.7. The top value I am substituting here. All W values I am substituting. Next, W11, W12, W13 is I will calculate. W11, what is the formula we have? Here we have this formula. This is a determinant. 1 into R13 minus R23 of R11. R23 of R11. Here this one. In the numerator part. So W1, 2. So like here, I will calculate this with the W1 value and W2 value. Yeah, W11 equal to. What is that, sir? Here, first row, first column, you eliminate it. This row, first row, this row and this column eliminated. Remaining elements, what we have? 1, 0.4, 0.4, 1. The 1 into 1 equal to how much? AD minus BC. 1 into 1, 1. Minus 0.4 whole square. Into W11 equal to. The total W value, this determined value, 0.84. Next, after that, I will go for the W12. W12 also same here. This is a 0.7 value. It is 0.7 minus 0.6 into 0.4. How much? 0.24. The subtracted value, 0.46. Next, 0.6 value. It's row and column limited. Remaining element, 0.7 into 0.4. How much? 0.28. Minus 0.6 into 1. How much? 0.6. So this value, I got it W11 and W12 and similarly W23. Here, W1 equal to W11 equal to 1 minus 0.4 whole square equal to 0.84. W12 equal to 0.7 minus 0.24 equal to 0.46. W13 equal to missing here. 0.28 minus 0.6 equal to minus 0.32. I got it the W1, W2, W3. B12 coefficients I needed. Coefficient sigma 1, sigma 2, sigma 3 already gave in the top, in the question only. Sigma 1, sigma 2, sigma 3. I want to calculate R12 and W1, W3 already I have. So in the B123 means what is that? Sigma 1, W12 by sigma 2, W11. W11, W12, W13 values we have. Sigma 1, sigma 2, sigma 3 values we have. Just as substitute, I got it. This is called as a coefficient of regression. So similarly here, B13 formula how much? It is a sigma 1 by sigma 3. W13, W by W11. So only W11, W13 we have. Directly I will substitute here. So I can get we get that is a regression coefficient. B11, B12, if I substitute, this is called as a regression coefficient. Alamma, Nilofer, understood or shall I explain on the board?
Understood.
Okay, Nana. Here sigma 1, sigma 2, sigma 3 he has given. R12 is a 0.7, R13 equal to 0.6. So this is the data he gave here. Now, what I want to find out here, W I should take, this is a general formula, you should take that. Note, this you should remember. Then here R12, R13, R21, R32 values he gives here in the top. Here. These values are available values, you take the values. Other values are the zero zone. Other values are the zero zone. So here I am taking that is available values means it is a 3 values is needed, 3 values he gave 0.7. So here the corresponding 1 0.7 here this is a 1 2 is a value and 1 2 1 a value also same. So 2 1 means the second or first column value also same. First or third column and third or first column is the same. First row, second or third column and third row, first second column also same. So these values directly I am substituting here. After substitution, I will calculate W11. W11 equal to first row, first column, you leave it. Remaining elements determined, minor. That is called as a 1 minus 0.4 whole square equal to 0.84. And 0.7, you leave it in row and column. Then 0.7 into 1, 0.7 minus 0.6 into 0.4, 0.24. So that is equal to 0.46. W13 equal to, this is the first, last to last column, you leave it. 0.7 into 0.4, 0.28 minus 0.6 into 1, 0.6. So this is a value. So here B12 of 3 and B23 of values is the formula. Directly you substitute all values, I can get the regression coefficient. That's it. This is the most important problem. Okay, similarly here, or about data, you can write it. These are the problems we have. Okay. In this chapter, we conclude that relationship between the variables of the data ordered triplets. It's a three variables data, how it will be there, that we can be checked. And what is a dots in the UL's notations we have observed. Next, after the number of secondary subscriptions of the, after the UL's notations, how we can be take, that is a W values to be identified. And subscription in the for the 2 variables. Then it is a subscriptions of the notations of the dot. It is a what are the values based on that regression equation we can identify the regression coefficients, we can identify that values we identified. From that here we can say that it's a secondary data, how it will be the second subscription, how it will be the effect on that single independent variable, and single way it is a x1 y on x1 and y on x2, like that we can be explained. This is the overall concepts is called as a this unit. Now I am going further as the next unit. Multiple and parallel correlation. Multiple and parallel correlation. Multiple and parallel correlations. Multiple correlation regression and parallel correlation and partial correlation and partial regression. These 2 topics we have to discuss here. Partial correlation, partial regressions, and multiple correlations. Also, how it will be there, that we will be discussed here in this unit. That is a 2 cases, 6.2 and 6.3. 2 topics. If you over, it will be enough. Now coming to the topic, it is a partial ordering. Means it is a it is involved. There is a more variables. At the time, one variable coefficients, how it will be the effect on the another variable coefficients. Such kind of the relationships is called as a partial correlation and partial correlation coefficient. And it is a correlation coefficients. Also, it is how it will be the effect on B1, 2 and B2, 1, like that. It is also that we can be verified. This is a simplification point of view. Here formulas are developed. Formulas are developed. The formulas here we can take now. R12 and R13 and R23. These are called as a partial correlation coefficients. Correlation coefficients. Partial correlation coefficients. Now here, correlation coefficients after calculation, here simply in your exam point of view, you will give the data and you will ask the question. What is that? It is a triplet data he will get. Tri-variable data he will give. That data, from that he will ask find the value of the partial correlation coefficients he will ask. Partial correlation coefficients, just now we have given the formula. In that if we substitute, is enough. So this is a R13, R23. These are the called as your partial correlation coefficients. Partial correlation coefficients. The derivation is not required, but the derivation is a part of it is involving, that is a one variable. How it will be, that depends on other variables. So independent variables, if more variables are depends on the independent variables are the changes, automatically dependent variable will be the changes. So the independent variable, that dependent variable clearly depends on the other independent variables. That is a concept is called as it is a dealing with the tri-variable at three data. And if I take tri-variable data, we call it. In the tri-variated data, it is a linear exact of linear effect. How it will be the effect in that exact solutions, exact coefficients effect that we will be identify here. So that is comes to the three variable involvement. So here we simply we should remember that it is a derivation part is not there. Just you should go for the formulas. You should be remember that is called as the partial correlation coefficient. In that partial correlation coefficient, simply you should substitute that value will give in the question values. So directly you will substitute in the formula. That is called as our required solution. This is called as our required first part of the value. Next is a partial correlation coefficient. Partial correlation coefficient. Partial correlation coefficient. What are the rules it will be followed? It means that first it is called as some properties I'm giving. In that it is a partial correlation coefficient. It helps in the deciding whether the additional independent variables should be included into the regression analysis or not. That is the first question. Next, second is a question is yes, it should be included. Then it is we can go for that. It is a R123. It means that it is clearly R12, it is depends on that R13 and R23. So that is a notation is clearly we can take R12, 3 means it is R13 and R13 and R23. These two coefficients are involved on that R12 of 3. That is the information we can be check it here. So here that is called as a R123 means R12, R13 and R23. And two regression coefficients, individual coefficients are involved into the at a time. That is information of R123. This implies that R12 will be not being equal to the 0. Because of if it is a one variable, it is a coefficient is a 0, automatically total coefficient will become 0. So that it is both are the different but not 0. That is only the information. Next, it is how we discuss it into the two variable cases. It is a three variable coefficients regression equation calculation point of view. How the regression equations we have seen that coefficients B1 to 3, that is a sigma 1 by W12 divided by sigma 2 by W11 of minus of that the coefficient, and B21 of 3 equal to minus sigma 2 by W21 and sigma 1 by W22. And this kind of observations on that, it is a total regression coefficient. If I want to identify that regression coefficient is a R12 of 3, that is called as a regression coefficient. Regression coefficient. So regression coefficient is there it is a correlation coefficient identified. It is a regression coefficient is a W12 by root of W11 into W12. This is a overall information. Next to multiple correlation. Multiple correlations, it is we will take the formula. It is a R12 regression coefficient and R13 regression coefficient and R23 regression coefficient. All three mixed up coefficients. Three variables so that it is a 1, 2 and 1, 3 and a 2, 3. That regression coefficients, one on that other, how it will be involved the regression coefficients. that all the regression coefficients on that we will identify multiple correlation regression. That multiple regression coefficient formula is clearly we can take here that correlation coefficient R1 to 3. It is a correlation coefficient we can be identify. That regression correlation coefficient is we can take R1 to this is a formula. This formula directly we can be used it here. Now here we can go for that. It is a R12. Here one variable is on that other variable, so that we can take this one and this one. So 3 formulas we can get here. That is called as a multiple correlation coefficient. Multiple correlation coefficient. Now properties here in the examination you will give the values and directly you substitute in the formulas. That is only our required answers. Now we can go for that. Properties of the multiple correlation. Properties of the multiple correlation. Always a correlation coefficient lies between 0 and 1 only. Next, R1, 2, 3 equal to R1. 1 is a depends on the 2, 3, it is 0. And R1, 2, 3 also 1. It is lies between the 0 and 1. So that we can take that is a total regression coefficient is not the 0. All will be lies between the 0 and 1 only. Next, it is comes to R1, 2, 3 is not less than 10. It is a total regression coefficient. So here he will give these are the values, and he will ask that is a regression coefficient, that a correlation coefficient, multiple correlation coefficient, that multiple correlation directly you substitute in that value, so that is called as a required answer. This is our overall idea. Okay.
Okay, sir.
Madam, please send link, madam. Okay, ma'am. Okay, now this is a oral idea about it, how we will form the unit number. Okay, yeah, up to here we will go over. Next class we will discuss about the data analysis. Okay, thank you. I will wind up the session. We will meet in the next class.
Okay, sir. Thank you.
Okay.